Hi there guys, welcome back to the channel. As you can see here, I've got a new project that I'm starting, and I've got some pieces of steel that I got my hands onto, and I'd like to use these to make up a set of pallet forks for the back of the tractor. Once I'd got the angle and the C-channel cut to size, I've then welded up the first two pieces into a T-brace to give me a nice solid framework to fix the 3-point linkage to, while also giving it a very sturdy frame for the forks to be mounted to and pivot and slide back and forth. As this piece had a cut off on the end, I've just used some bits of scrap to make up some reinforcing gussets to strengthen the framework yet again. That's the gussets now welded in place. So I've now got this T-frame welded together, and I've also got the forks on the bench here, and I've picked up some bushes here which worked out cheaper to buy pre-made bush than to buy the solid bar and machine it out myself. So this C-section channel is 150mm wide, and the bushes that I could get were 120, so they're a little bit narrower, but that shouldn't be a problem. It'll give us a chance to get a good bead down both sides, and maybe even a little one on the end here, and that's going to give the forks somewhere to pivot from and to slide in and out to give me adjustable fork width for different size pallets. So I'm just going to head outside now and clean off the paint on these bushes and on the C-section channel here. So with these parts now cleaned up, I've got them set up on the little fixture plate here. Just getting close to the limit of what I can fit on this plate. I have actually got another one to double the size, but it means stripping it off my mill, and I really can't be bothered to do that at the moment. So I've got these bushes lined up with a shaft through them to make sure they are properly aligned and going to be symmetrical, and I've measured the depth from the rear of the forks to make sure I've got enough depth to poke out onto the back of the angle here, and then the bushes are going to go on the front side of this angle here, and then I can put 4 locating holes in the bottom of this heavy duty angle to give you some locking points for each position of the fork. So with these bushes now welded in place, as you can see, got a good few passes on those and a little bit of splatter everywhere, but I'm really pleased with the penetration of those welds. Really pleased with how those have came out, and those bushes are not going to peel off those tines anytime soon, as this fork that I'm making is just to lift dumpy bags and crates full of logs, so it won't be lifting much more than a ton ever, so these should be more than substantial. So here I'm using my Artec 30 amp plasma cutter at 30 amps running 75 psi. I think I maybe should have turned it up a little bit higher, but it seems to have done the job. Cutting through some 12mm thick plate using some 6mm plywood as a rough template to get the profile for the part. As you can see, halfway through the plywood just burnt away, but it did the job, and just clean up the slag off the parts here using my fireball scraper. So I'm pretty pleased with how that template has worked using plywood. As you may have noticed halfway through, it kind of burnt away, but it did the job of cutting these 4 brackets. As you can see, they've got gradually smaller as the cuts have continued, and 2 of the sides here are really jagged. It's asking a bit much of this 30 amp machine cutting 12mm plate, but I thought I would give it a go, and that's just on a standard 13 amp plug, so I may be able to get a bit of a better cut if I had a higher amperage feed, but the breaker didn't trip, so it's not actually pulled any more than 13 amps. So I'm going to just put a couple of tacks between these plates, and then I can get them set up in the machine and square off the back edge. Then I've got a reference to measure from, and then I can drill and bore the hole through for the support bar for this 3-point link fork setup, as I didn't want to use the plasma to cut the central hole. As you can see, the edges are just pretty jagged and it ends up being too hard, so machining afterwards is a bit difficult, especially in a bore. So I can take the sides off, no problem, square it up, that'll not be an issue, but for opening up the bore to a nice snug fit, I just felt like doing that on some raw plate rather than trying to punch through it with the plasma. So we'll get some tacks laid down and then we can get this in the machine. So I've got this bunch of brackets tacked together and set up within the vise. I just used a pair of parallels on the side there just to give me a bit of a reference to set the part down to, and I'm just needing to skim these all 4 nice and flat so that I've got a reference surface to then take my measurements from, as it's only the back side of these brackets that are going to have to actually mate up against anything else and then be welded around. So we'll get this skimmed flush and then we'll be ready to machine the bore. So my phone battery died as I was in the middle of skimming these faces off, but I've got 2 edges now skimmed flat, and I've got some scribe lines here giving me my center point, and I'm just set up going to do a center hole there, and then I've got a point to work to with the larger drill bits, opening this up to 10mm to give me a center point to then fix it to the dividing head. So I've now moved this dividing head into the vertical position, and I've got these parts set up as I just like to clean up the outside face, as the plasma cut edge on this 12mm plate is just a little bit jagged. I may have to play around with the air pressure settings, as I believe I still had it set on 75 psi, so I might have to try cutting some 12mm with some higher pressure, see if that clears the material faster. But at the end of the day, it's only a 30 amp machine, and I feel like that might be kind of at its limits. It's basically a severance cut rather than a clean cut. So I'm just going to use the rotary table here to weigh the dividing head, just to clean up this outside radius and then remove these really bad looking edges here. just to get it looking a bit more uniform. And then we've got a bit of a squarer part to get clamped in the vise and complete the board. So after a little bit of faffing about, I've now got this vise moved back 1 T slot to give me the achievable depth for my tooling, and I've had to take this piece out of the dividing head, and I've skimmed the face on this leading edge there, as I just wasn't happy with the finish and the amount of material I was able to remove with just a rough and end mill. So I moved on to the shell mill and just skimmed the worst of the rough cut edge off. I've also taken the high spots off this radius, but I didn't want to remove too much material, so there's a few little bits where it's not quite a perfect machined finish, but I'm not really too fussed. It's more about being structural than looking finished. So I've got this part lined up now, and I'm going to drill through with this drill bit, which is a 1.1 size drill bit, I believe. And that's going to give me just under 30mm bore, and then I can get the boring head to finish the bore to the final dimensions. Then we'll have a nice slide and fit for the shaft that's going to go through these brackets to support the folding forks. So I just used a 1, 2, 3 block there just to get the known parallel face squared up with the vise and the table of the machine. Then I can skim off these last welds, as we've got the holes started through all 4 parts now. So now all these parts are squared off, I have got them set back up in the milling machine, just using a bit of copper wire there to account for the discrepancy in the face flatness on the rear side there, and that just allows it to clamp nice and securely onto all four parts, even though all four faces are slightly different. As even though I've cut a radius onto that face, obviously the point of the radius isn't perfect on all four faces there. So I'm going to get centered up on this bore, which is 28.5mm, and then I can use the boring head to open this up and get a nicer finish to a 30mm hole, and then we're ready to get these parts chamfered and then welded onto the main frame of the rear loader. Here I'm using a pneumatic chamfering tool to add a decent chamfer to the parts to help penetration for the weld and make for a good solid bond between these support eyes and the main framework. So I've just laid these parts out together there just to see if everything's marrying up where I hoped it would, and you can see now the idea with those brackets. They're going to give good support to this shaft all the way along, and then the forks can slide along the shaft to give you probably 4 different locations for different pallet sizes. And I'm going to leave that central gap wide enough so I could put one of the forks in the center if I ever needed to. So I just need to get this main framework cleaned up a bit, and then when I come to weld these brackets on, I'll put some washers or a little bit of filler rod between the two pieces to give a good gap, and then I can get some full penetration welds on all these joins. It's going to be more than strong enough for lifting around a ton. So I didn't manage to film it, but I've got all these brackets now welded up and solidly secured to the main framework of the pallet fork attachment. So moving on, I'm now set up with the bolt hole positions marked out for fitting a toe ball to this framework, and that's going to make this set of forks pretty universal use attachment, and I can then move things around, lift things up and tow things around, so that's going to be spot on. I've also got some Conus 2 tine bushes to go into the center of the frame, so in the future if I ever have any round bales or straw to move, I can shove a spike in and shift them with the tractor as well. So we'll get this mag drill set away here and get these 2 holes punched through. Get some lube on the job. Love a bit of anchor lube, really good stuff. Doesn't stink the place out and improves the tool life. Magnet off, and then just move this drill across to the next hole. Get me centre punch lined up. Flick the magnet back on, check we're still lined up. Cut is still tight. Get a bit of lube on the job, and we're ready to go. So as you can see, just peck away at the hole, as I'm not running the flood coolant that you can on this machine, just as it makes a bit of a mess. So I'm just using the anchor lube, which works a treat, but about halfway through I could have probably topped up with the lube there, but if you just peck away it stops the tool overheating, and especially on thicker material like this, it's definitely going to improve the tool life. So as you can see, I've now got the toe ball installed into the framework there. The mag drill really helped drilling through that thick angle here, and that's going to be more than substantial for shifting some things around. Obviously I wouldn't use this really to tow anything on the road, but for just moving bits around out the back and on the bit of land we've got, that's going to be spot on. So I'm just set up this next hole in the centre of the upright, and it's the centre of the height of it as well, and this is going to do for giving me a hole to set up for the boring head, and then I can open that hole out to receive the Conus 2 sleeved bushing. So I've moved over to the milling machine here, and I've got the part set up. Got it supported using the overhead crane here, just to take a bit of the strain off the table and keep it nice and level. And as you can see, I've got my hole started there with the mag drill, and that gives me a point that I can centre the boring head off. And then I've got the tapered Conus 2 bush here that is 54.9mm wide, and I'm going to open this bore up to be a nice snug fit, so I can slide this bush in place, and then it can be welded from the front side, and then put a square spreader plate on the back side with a hole of the matching diameter in to support the back side of the bush, and that's going to make it really stout and nice and solid for any future use. See where we're at the moment. That's a problem. $53.9, so we've got away. Yeah, 54, I would say. So we've got another mil to go, really. Set up for round 2 here. Just reverse this for a second. And then run it forwards to start the cut. And it's looking like I need to change the insert. Either that or the boring bar is now covered, because that is not cut and clean anymore. So at this point I realised that I needed to remove the crane from supporting the job, as when I had moved the table down previously it had actually moved the job, and that's what's caused the insert to get broken. So I've just roughly cut out a reinforcing square here for the rear of this upright to take the back side of this cornice to bushing, and I'll do the same. I'll bore a hole in the centre there, and then this sleeve can slide through both the front and rear face and get a good bead around the outside on either side, and then that bush can be removed in the future fairly easily if it ever needs to be. So I'm really pleased with that. Now this is 12mm plate, and I used a variable pitch hacksaw blade on the porter band, and I'm really surprised at how well that cut. And it's safe to say, if you can get the reach into the throat of the saw, that's 6-inch square, and my saw only has 5 inches of horizontal travel, but if you put the plate on an angle into the throat you can achieve slightly more throat depth. So I'm just set up now in the Colchester master lathe here, using the 4-jaw chuck and the live centre. I've used a centre point on this square plate into the live centre to give me a quick and easy centering setup for the 4-jaw chuck, and then I can set up and drill out this centre hole wide enough to receive the boring bar, and then open it up with the boring bar to the desired width, as this will be much quicker than doing it on the milling machine, and with this pot I can fit it in the lathe. So we're going to set to get that done this morning. Then we've got the support bracket for the back of the A-frame and the cornice to bushing. So I'm set up for drilling this hole out here, and I'm going to use a large twist drill an Morse taper 3 twist drill here, just to get as much rigidity in the setup as possible. And because it's about midday and I haven't ran this machine yet, and this operation is going to be a slow speed operation, I've just ran the machine up at 500 RPM for a couple of minutes just to get some oil thrown around in the inside of the headstock, as on these machines the spindle bearings are fed by oil slinging onto the headstock casing and dripping down into a oil way. So when the machine's not been running for a while, it's always good practice to just run it up at a higher speed, then perform the task you want to actually do. So when it's getting the cutting forces, the bearings have got some lubrication. So I'm going to set up here at 130 RPM and see how that performs. Nice and steady. Going to get a little bit of anchor lube on the job here, just as my coolant tank could do with a bit of a clean out, and haven't done that job just yet, so I'd like to just prolong the life of this drill bit while I perform this job. Make sure the tailstock's locked up on the ways, and just to say, nip the quill lock. May even need to slow that down just a little bit. Put it down into a slower speed there. We'll go for 85 RPM. That sounds a bit better. There we go, so that's now opened up and ready to take the boring bar, and then we can open this up to the desired diameter. So I'm now set up with the boring bar, and I'm going to open up this diameter to receive the Conus 2 bushing, which is a diameter of 55 mil, I believe, if I remember rightly. So I'm aiming for 55 mil, and we've got just under 25 there at the moment. So I'm just gonna get her opened up a little way and then get a measurement again and see where we're at. So let's just get a measurement of this cleaner bore. So that's 26.8, and we're aiming for 55, so we've got quite a way to go. So I'm just gonna check where we're at. So we're at 40.6 there, 40.7, 40.7, yeah, that's fine. So we've still got 15 mil to go. Just start her up, touch off and get going again. 53, hang on where I wanted it to be. Now I just need to wind out 1 mil, which will make up 2 mil in the diameter. Zero my clock out and just compare the clock to the DRO. So I'm just going to back this off the 10th. So I'm aiming just under size here, and then I can get a final finish pass on the go. .7, so I want 0.3, so 0.1.5 on the diameter. .9 there, so it would go 0.5, do another spring pass, but I'm just going to try the bush as it is, as I think that would be a nice snug fit. Just to say it doesn't want to go in on the thicker side of the bush, and that's pretty much a press fit that, so I'd like it to be a sliding fit, so if the bush needs to be changed in the future it will actually come out. So I'm just gonna touch off the tool again, just to the bore, and then run a spring pass through there. So that's bang on 55 there. That's really good. That should take this bush in, no problem now. That is the kind of fit I am after. Spot on. Just double check both ends fit. Definitely a little bit snug on that wide, on the tapered side. But I do believe that this part is actually out around slightly from the manufacturing process, as that's just got a little too tight in there. But I'm happy with that. Put a little chamfer on both sides and that'll be spot on. So I've just spent a bit of time getting this plate lined up here with the bush poking through, and I've got a depth stop here, so I've got an equal amount poking out of both sides to receive a nice bead of weld all the way around. And this bushing currently can slide in and out nice and freely, so that proves that both bores are in proper alignment. And I've checked with my small square here just to be sure that the bush is actually in alignment, which it is from both sides there. So this is now ready to lay some beads around both ends and get this plate tacked to the main framework as well before I do the bushing welding. So for these lower pins, I'm drilling out some channel to allow 3 fixture points for the lower pins to give me some different mounting positions depending on what kind of tractor you use to hook up to this attachment. You may want to be slightly higher or slightly lower, or depending on the item you're trying to pick up, you may need a little bit more reach. I'm just using the mag drill again just to open up these holes to 22mm in one pass and not need any extra machine work to complete the job. Once we've got the lower link frame cut to size and squared up, I've just run some tacks around the part there, then remove my clamp and finish all the beads and get it secured into the framework. So I've just used the mag drill here to drill out this top link hole, and I've left 45mm clearance to the center of this hole to the inside face of the channel, which is going to give me plenty clearance for the eye that is on my hydraulic top link. And you can see the framework lower down that I welded in the previous videos. I've put 3 fixture holes for the pins on either side to give you height adjustment depending on the machine that you use to connect up to this. And I've also cut some 10mm extra thick, extra large washers. Just rather than welding them on, I'm just going to leave them loose, and then if you adjust the pinhole, you can then adjust the washer's position at the same time, instead of having 3 extra thick plates I'll just have the one, and then it can be moved if I ever change the pin position. So the height between the lower link pins and the top link pins is about 500mm, and with having a hydraulic top link, that's not going to be an issue, as I can adjust the length quite easily. So we're getting really close to being able to get this on the back of the Dexta and test it out, as we've got a few things I could do with moving around, and this is going to make the job much easier. So I'm just set up here using the mag drill again, and I'm just going to drill out a central hole here on this little tab that I'm about to cut off. And before I cut it to length, I've left the length under the magnets so I can drill the hole. And this central hole will allow me to put a bead of weld round the centre and attach this fixture lug to the end of the pivot shaft, and then that can be bolted through one of these eyes, and then we know the shaft's never going to wobble out under use. So with that hole drilled, it's ready to be cut to size and welded onto the end of the shaft. So just before I weld that fixture lug onto the end of the shaft, I just chuck this shaft into the lathe and put a nice heavy chamfer on the end that's going to be sliding in and out of the eyes, just to ease the fitment in the future. So this is how I'm going to attach this little lug to the end of the shaft, and then I can get a fixture bolt through here to stop the shaft from being able to come out. So that's just a quick test fit of an M10 bolt through the fixture lug there to keep that pivot shaft in place, and I'm really pleased with how that's looking. So we'll get the forks put on and get this tested out. With the forks brought round the back, the following day we got them connected up to the Dexta and gave them a good test out. Without any counterweights on the front, as you can see, the steering is still pretty light and doesn't really do very much. So I had to put my phone down and remove the pin for the split brakes and use the brakes on either side of the wheels to steer as I drove forward. And you can see here, using the hydraulic top link, I'm just leveling out the pallet, getting it in a nice flat position, and makes for a much more stable ride whilst driving along an uneven surface. With this first load of stone and a hydraulic stone splitter shifted up the hill, I'm pretty pleased with how these forks are working out, and I'm certainly going to get some use out of them over the next few months. I just really need to get the front weight sorted out on the machine, and then we'll be ready to go down the road and not be wheeling every chance we get. So again, you can see I'm using the hydraulic top link here just to pull the forks up and give us some good ground clearance for when I'm coming down the hill. With that, I'm going to end this video and thank you all for watching.